We're given that z1 is equal to 6e to the pi by 3i, and z2 is equal to 6 root 3 e to the 5 pi by 6i. We want to show that z1 plus z2 is equal to 12e to the 2 pi by 3i. So let's start off with z1 being 6e to the pi by 3i. That means that it is 6 cos pi by 3 plus I sine pi by 3. Since cos pi by 3 is a half and sine pi by 3 is root 3 over 2, that is going to be 3 plus 3 root 3 I. Now let's have a look at z2, which is 6 root 3 e to the 5 pi by 6i. So that's going to be 6 root 3 cos 5 pi by 6 plus I sine 5 pi by 6, which is 6 root 3 into cos 5 by 6 is negative root 3 over 2, and then we've got half I, since sine 5 pi by 6 is a half. And so we can simplify that into negative 9 plus 3 root 3 I. So if we add them, z1 plus z2, that is going to be negative 6 plus 6 root 3 I. So let's have a look at where that is. So if we just have a quick sketch, negative 6 plus 6 root 3 is going to be up here. This will be 6. This will be 6 root 3. The angle here would be pi by 3, meaning that this angle here is 2 pi by 3. And the square root of 6 squared plus 6 root 3 squared is equal to 12. And so it is equal to 12 cos 2 pi by 3 plus I sine 2 pi by 3, which can be written as 12e to the 2 pi by 3 I. Now let's look at part 2. Given that arc z minus 5 is equal to 2 pi by 3, determine the least value of z, mod z, as z varies. Okay, so arc z minus 5 is going to originate from 5 on the real axis. And if the angle is 2 pi by 3, it's going to go off in this sort of direction like this. So this angle is 2 pi by 3. And we want the least value of mod z, which is going to be when that's a right angle. So we know that this length here is 5, and we know this angle is pi by 3, or 60 degrees. Therefore, this being the opposite of this right-angled triangle, we know that the smallest value is going to be 5 sine pi by 3, which is equal to 5 root 3 on 2.